Hello and welcome to helpyourmath.com. In this video, we're going to look at writing linear equations given the slope and 1 point on the line. And we're going to look at two different forms. So first, we're going to look at writing it in point slope form and what information do we need to write it in point slope form, or conversely, what information would the equation be telling us if it was written in point slope form. And it's pretty straightforward, right? We need 1 point, any point on the line. So the point we usually say is of the form x1, y1. And we also need the slope, m. So if we have those two pieces of information, then we're able to write it in point slope form. And point slope form is we say y minus y sub 1 is equal to m times x minus x sub 1. So we plug in for y1, m, and x1. And then that tells us, right, so if it's given in that form, then we know 1 point on the line and we know the slope as well. The other form we're going to look at is slope-intercept form. So when it's written in slope-intercept form, it tells us the slope and one of the intercepts, specifically the y-intercept. Slope-intercept form we're usually pretty familiar with. It's y equals mx plus b. So we keep x, y as any point on the line, m is the slope, and b is the y-intercept. And generally, when we're looking at these examples, we're going to go from point slope form straight into slope-intercept form. So let's look at our first example. We have a point on the line is -1, -2, and the slope is 3. So I'm going to label this. This is x1, y1, and m is already labeled. So to put it in point slope form, remember this is y minus y sub 1 is equal to m times x minus x sub 1. So I'm going to substitute in for y sub 1, and I'm going to substitute in -2. Y minus -2. We want to be really careful there because sometimes we see the negative and we're like, look, the negative's already there for us. No, no, no. This is a subtraction that's part of the formula. This is a negative that's attached to the coordinate, so it becomes minus negative. Equals the slope 3 times x minus x sub 1, x minus -1, right? Again, we have that negative minus negative. In both the left-hand side and the right-hand side, we can rewrite the minus negative. Subtracting a negative is equivalent to adding a positive, so we could write this as y plus 2 is equal to 3 times x plus 1. Next, I want to distribute the 3 on the right-hand side, so I have y plus 2 is equal to 3x plus 3, and I'm getting carried away here because actually, if I stop right here, this is the end of the first part. That is point slope form. So that's part 1. There's the answer to part 1. I got a little carried away. I'm going to try to remember to freeze when I get there next time. Okay, and so then again, what this tells us is that we know the slope because it's right here, and we know 1 point on the line because it's going to be the opposite of this and the opposite of this. So -1, -2, which we see up here, and the slope of 3. This is me getting ahead of myself, writing it in slope-intercept form. So to get this in slope-intercept form, you'll notice from the formula that we need to get y by itself. So that's what I started doing. I distributed the 3. Now to get y by itself, I'm going to subtract 2 from both sides. And the slope-intercept form of this equation will be y equals 3x plus 1. So this is one version, or one form of this linear equation, and this is one form of this linear equation. Those will be the same equation. And we can double check our work because we could plug in the point -1, -2 into our slope-intercept form and make sure that we do end up with a true statement. If we were to plug it in, we would get -2 equals 3 times -1 plus 1, or we're going to put a question mark. That's -2. Does that really equal -3 plus 1? Yes, it does. So these do work out. We do have two equations for the same line, representing the same line. How about this example? So here we have the point -4, 1, and the slope of 0. Wait a minute, slope of 0? That's a special kind of line. What kind of a line has a slope of 0? This is a horizontal line. Now, we can use the fact that if you don't remember that, that's okay, because look what happens when we go to put it in point slope form. If we put it in point slope form, this is x1, this is y1, and we'd be plugging into y minus y1 equals m times x minus x1. So if you forget, you plug in and say, okay, y minus 1 is equal to 0 times x minus -4, and then I would just clean this up. Y minus 1 equals 0 times x plus 4, and this would be our point slope form. This is pretty unusual. Normally we wouldn't see it like this, but hey, it happens, and this is what it would look like. Then from here, to get it into slope-intercept form, Well, 0 times anything is just 0, so we would have y minus 1 equals 0, and then we would add 1 to both sides, and we would have the equation y equals 1. Now, a slope of 0 does mean we have a horizontal line. Horizontal lines are always of the form y equals, and we can fact check ourselves. We have y equals 1. Is that what y equals here? Yes, it did. So we're good to go. I feel pretty confident that I did something right here. So we have our two different forms. A little bit strange with our horizontal line, but we can still make it happen. Okay, how about this example? Here we have x1, y1, and we have a slope of -3/4. So for the first one, to get it in point slope form, again, that's y minus y sub 1 is equal to m times x minus x sub 1. We're just going to plug in what we see, so y minus -5 equals -3/4 times x minus 2. We want to clean up the left-hand side, so we're going to say y plus 5 is equal to -3/4 times x minus 2, and here is our point slope form. So we have our point slope form right here. Now we're going to use the point slope form to write the equation in slope intercept form. I need to distribute the -3/4. I'm going to come over here and start up here. So that would be y plus 5 is equal to -3/4 times x. And then I have negative times negative, which will be positive, so I'm only going to focus on 3/4 times 2. I'll put 2 over 1 when I'm multiplying, and then I see I have a common factor of 2. That's all I can do, so I end up with 3 over 2. So this will be plus 3 over 2. Now to get y by itself, we're going to subtract 5 from both sides, and that gives us y equals -3/4 times x. Okay, now I'm trying to, add or subtract. When I'm adding or subtracting fractions, I need a common denominator. I have 3 over 2 minus 5 over 1. The common denominator between 2 and 1 will be 2. I'm going to multiply this fraction by 2 over 2. So this gives me 3 over 2 minus 10 over 2, and that would be -7 over 2. So -7 over 2, or if you want to write -3.5 or 3.5, that's fine too. And this would be our slope-intercept form of the same line. Okay, last example. Wait, slope is undefined. So we actually can't put it in point slope form, nor can we put it in slope-intercept form. We can write the equation, but it's not of either of those forms because there's no slope. We can't do anything with slope because it's undefined. Undefined indicates to us that we're dealing with a vertical line, and vertical lines are always of the form x equals something. So I usually say x equals a. And in this case, what does x equal? X is equal to -4. So the equation of this line would be x equals -4. And we can't put it in either form. That's just what it would be, is x equals -4. These have been examples of writing linear equations in point slope and slope intercept form when we're given the slope in one point on the line. Thank you for stopping by.